and implement a queue, and we're going to use an array. So I've created a project. I'm putting the code into package academy.learnprogramming.queues, and I've copied over the usual employee class, no changes there. So the first thing I'll do is create a class for the queue. So I'll say new Java class, and I'm going to call it array queue. And then we need 3 fields in this queue. We need one for the array, we need one that's going to track the front of the queue, and we need one that's going to track the back of the queue. So I'll say private employee queue, private int front, and private int back. Now, as usual, I'm not using generics. I could have created a queue and used generics, and then the queue can be used with any type of object, but I want us to just focus on the queue implementation. So the front and back fields will initially be 0, just as top was initially 0 for the top of the stack. So when we first start out, front and back will both point to 0, and so we don't need to initialize those in the constructor. We just need to create our array. So we'll say public array queue, and we'll let the caller tell us the maximum number of elements they want in the queue, and we'll say queue equals new employee capacity. All right, so now let's talk about adding an element. We're going to want to add elements to the back of the queue, and we'll have to worry about resizing the array when the queue is full. So for this implementation, the front element is always at index front, and the back element is always at index back -1. So if you'll remember, when we implemented stacks, the top field was always pointing to the next available position in the stack. Well, it's the same with the back field. The back field will always be pointing to the next available position in the queue. And so if the back is, let's say, pointing to position 3, then that means that the end of the queue is actually at position 2. And so the end of the queue is actually located at position back -1, and back is where we would add the next element that's coming into the queue. So when there's no elements on the queue and we add an item, we're going to add it at position 0, because when we first create this instance, front and back are both 0, and then we'll increment back to 1, because 1 will be the next available position. And so after adding the first item, front will be 0 and back will be 1. If we add another item, front will still be 0, we'll add the item into position 1, and then we'll increment back to 2. And so when we add an item, the front field never changes, because we always add items to the back. All right, so let's implement the method for adding an item to the queue. So we'll say public void add, and we're going to accept the employee that we want to add. And the first thing we're going to do is check whether the queue is full. Now the queue will be full if back equals the length of the queue. Let's say we create a queue of 10. Well, when back equals 9, the next available position in the queue is 9, and that's fine. We can put an item there, but then we'd increment back to 10, and the next available position would be 10. That would be an index out of bounds exception. So once the back equals the length of the queue, we need to resize the array. So we'll say if back equals queue.length, and we're going to resize the array exactly the same way we did it for stack. So we'll say employee new array equals new employee, and we're going to double the current size, so 2 times queue.length. And then we need to copy the existing items on the queue over to the new array. So we'll say system.array copy. We're going to copy from the queue. We're going to start from the beginning. We're going to copy into the new array, starting at the beginning, and we want to copy queue.length elements. And then finally, we're going to say queue equals new array. And so far, this is looking exactly like the push method. And then once we're sure that the back field isn't going to point to an invalid index, we just go ahead and assign the new employee to back. So queue back equals employee. And then finally, we want to increment back. And that's it. That's our add method. We check whether the queue is full. If it is, we resize the array. We assign the employee into what back is pointing to, because back always points to the next available position in the queue. And then we increment back. Okay, so now let's remove an element from the queue. So we'll say public employee remove. We always remove the first item on the queue, so we don't need to pass anything. Now, the first thing we need to check is whether the queue is empty. And how will we do that? How will we check whether the queue is empty? Because as we add and remove employees, the front and back positions will be changing. Well, we should be able to subtract front from back, and that will give us a number of items in the queue. Remember that back is always one position greater than the end of the queue. So let's say when we first create the queue, we come in and we add our first item. So we just saw that when we add our first item at the end, we'll increment back to 1 and front is 0. So we have one item on the queue, back is 1, front is 0, back minus front would be 1 minus 0, which is 1. So we have one item on the queue. If we came in and added another item, back would be incremented to 2. We don't touch the front pointer when we add an employee because we're always working at the back of the queue. So if we came in and added a second employee, back would be incremented to 2, front would still be 0. 2 minus 0 is 2. We have 2 items on the queue. If we then removed an item from the queue, we're not going to touch the back pointer because we always take items off the front of the queue. So what we'll do is increment, as you'll see in a minute, we'll increment the front of the queue. So we'll increment front to 1. And so at that point, we'd have 2 minus 1 is 1. And so we started out with 2 employees on the queue, we pulled 1 off, and we have 1 left. So basically, we can get the size by subtracting front from back. So I'm going to put that into its own method. So I'm going to say public int size, and we're going to return back minus front. Now, if you're really astute, you may have noticed something a little bit weird about the add method. Don't worry, we're going to come back to that. So in the remove method, we're going to say if the size is 0, meaning there's nothing on the queue, then we're going to throw a new no such element exception. And that's in the java.util package. So if you try to remove something from an empty queue, we're going to throw an exception. If that's not the case and there's something on the queue, well, we always take elements from the front of the queue. So we're going to say employee equals queue front. because that's the employee we're going to remove. Then we're going to null out queue front. This is just doing a bit of cleanup. We're then going to increment front, because if we started out, let's say front is 1, we want to remove the employee at position 1. Well, after we've done that, the new front of the queue will be 2, because the new front will be the next employee in the queue. Now, there's a bit of an optimization we can do here at this point. At this point, we can check whether the size is 0. If we've removed the only item on the queue, so if size equals 0, then we can reset the front and back positions back to the beginning of the array. So we can say front equals 0 and back equals 0. So if after pulling off the employee, there's nothing left on the queue, we'll just reset the front and back. So it's like resetting the queue to an empty queue. And then finally, of course, we want to return the employee that we pulled off the queue. And so to remove something from the queue, we first check to see if the queue is empty. And if it is, we throw an exception and we're done. Otherwise, we save the employee at the front of the queue into employee. We null out that position in the queue, just a little bit of cleanup, and then we increment the front field because the new front of the queue is going to be at front plus plus. And then we check the size. And if there's nothing left on the queue, so basically we remove the only employee, then we set the front and back to 0. So we're basically resetting the queue. And finally, of course, we return the employee. And so we still have our peek method. So I'm going to say public employee peek. And just like with the remove, we're going to check if the queue is empty. And if it is, we're going to throw an exception. So I'll just copy the code from there. Now, if the queue isn't empty, we just want to return the employee at the front of the queue, but we do not want to remove the employee from the queue. Remember, when we peek at a stack, we return the top of the stack, but we don't change the stack in any way. It's the same thing with the queue. We return the employee at the front of the queue, but we don't change the queue in any way. So all we have to do is say return queue front, and we're done. We don't want to change the front field. I'll just delete that blank line there. And that's it. That's our queue implementation. Now, one final method I'll add is a method to print the queue, so that when we start playing around with our implementation, we can print out what's on the queue. So I'll say public void print queue. And our queue is an array, so this should be fairly simple. We just have to keep in mind that if we're going to print the queue from front to back, front might not be 0. So we'll say for int I equals front, I less than back, I plus plus. And I'll just say system.out.println QI. Now remember that the back points to the next available position, so the end of the queue is actually at back -1, so we only want to increment I until I is less than back. When I equals back, we're actually 1 beyond the back of the queue. Okay, so now that we finished our implementation, let's go to the main method. I've already added the code to create our usual 5 employees. So let's create our queue. I'll say array queue equals new array queue, and I'll make it 10, just like I did with the stack. And let's add employees to the queue. So I'll say q.add Jane Jones, q.add John Doe, q.add Mary Smith, q.add Mike Wilson, and finally q.add Bill End. And let's print our queue, q.print queue. So let's go ahead and run. And we'll see our 5 employees. Now this time, they're printed out in the order that we added them, because this isn't a stack, so we don't see the items in reverse order. We added Jane to the queue first, so she's at the front of the queue, and then we added John, so he's second in the queue, then Mary, then Mike, then Bill. So let's remove 2 employees. And we expect to remove Jane and John because Jane is first in the queue and John is second. So we'll say q.remove, and we'll do it again. And then let's print our queue. I'm going to comment out that print queue. So let's run. And we'll see that we only have 3 employees left on the queue, Mary, Mike, and Bill. So Jane and John have been removed because it's first in, first out. So Jane was first in, so she's first out, and then John was second in, so he's the next one to be taken off the queue. Okay, so let's peek at our queue, and we should see Mary. So I'll say system.out.println queue.peek. And let's print our queue after that to show that the queue wasn't changed. So I'm going to comment out that print queue. So we're going to peek at Mary, and then we should see the exact same printout for the queue, because when you peek, you don't change the queue. So let's run. And we'll see Mary printed twice. This is from the peek, and then this part is the print queue. So we peeked at Mary. We were able to see what the first employee on the queue is, but we did not change the queue. All right, so just for fun, let's remove the remaining 3 employees and then print our queue. So I'll comment out that there, and I'm going to add 3 more queue.removes. So let me copy this here, paste this here, and I'll add 1 more. And we should see nothing printed because our queue should be empty. We're just testing to make sure nothing bad happens when we pull the last employee off. And indeed, we don't. Now, if we were to do a 6th remove, at this point, the queue is empty. So this 6th remove should result in a no such element exception. Let's try it out. And indeed, that's what we get. On line 29, right here, we get the no such element exception. I'm going to comment out that last queue.remove, and let's try adding an employee now, just to make sure that when we remove the last employee, we properly reset the front and back, so there's still room in the queue. Let's add Mike Wilson. And here's a print queue here, so let's run. And only Mike is on the queue. So that's it for our implementation. Now, if we go back to array queue, and let me just close this down, I said there's something weird about this add, and it's actually here when we're checking whether the back equals the queue.length. That's the check we're using to see whether the queue is full. Now, I want you to think about what would happen in this situation. Let's suppose we add 2 employees, and then we remove an employee and we add another employee, and we remove another employee and we add another employee, and we keep doing that. So we never have more than 2 employees on the queue at a time. Do you think that the array should be resized? The answer should be no, right? I mean, if we have a queue of size 10 and we only ever have 2 employees on the queue, the array should never have to be resized. But with our implementation, will that be the case?